It's normal in your third year, those of you who are in your third year, and those of you who are in your second year, most of you, or those of you who are in your third year, it's normal that these courses are more difficult than any other courses, okay? The thing to watch out about your degree is the third year is always the year that you struggle most, and it's normal. Because why? When do you feel most pain when you run your marathon? Is it the first 10 kilometers? Is it the last 10 kilometers? It's the middle, and it's normal. Are we clear? Okay. So the toughest time, all these over here are your level 3 courses. Starting from 3RO3. It's a bloodbath. You see that? And this was taught by the previous instructor that retired, is Dr. Ross Judd. By the new instructor, I love her to hell. She's like the female version of Ross Judd. Okay, it's good and really train you well. What's below the list? This course. Okay, what's below the list is this course. Are we clear? Okay. And then if you look at your, so this is year 3. So level 3 usually is normal to have what? Problems. 3E05, which I showed you the exam earlier, now is known as what? 3E03. When it was 3E05, the students were lucky. You want to know why? They had projects. Now you have what? Nothing. No projects. Are we clear? So if you are going to protest, okay, go to the mechanical engineering department and protest that you need it to be what? 3E05. Are we clear? Okay. So now, yeah, 3E03 is tougher now than before. Are we clear? Okay. That's where I have to. Now, the good news is this. These are all holiday courses. These are all your level 4. Can you all see the level 4, how dark is dark? Are we clear? Okay. And I'm going to give this to you. You plan your courses. Are we clear? Okay. You plan your courses what? Accordingly. Based on the information that I have what? Given to you. And use it as a what? Strategy. Are we clear? I can't tell you now, is it more black or less black? I can't tell you. Okay. We don't have the data yet. Are we clear? Okay. So before I go on, oops, yeah, this guy is brutal, okay? It's killer, okay? Right. Anyone, any other question before I go on? Yes. Don't know yet. You have just come to the class. 2Q. I don't know what's the average for the final, but the average grade cumulative for like final grade. Holy shit. Wait. I don't know yet. Wait, okay. But there was a gentleman that got 100. And I'm looking at the grade now. Can you see anything? You can't, right? The average was a 66%. Okay, and that's normal. Say it again. Yeah, 66 is a C. Okay. Any other questions? Yes. Say again. Yeah, I'll provide for you. It's to help you. It's not to harm you, right? Okay. Yep. Okay. Let's talk about this course now. So again, your assessment is by homework, okay? And then you got 2-term tests, and you have your final exam, and you must pass your final exam to pass this course. Are we clear? Okay. Any other questions before I show you what is expected? Yes.
The beer prevention.
Yeah, no. Let me think twice, okay? If let's say half the class fail and then the faculty of engineering is up my butt, yeah. Okay. Okay, but let's not go there. Okay, let's think positive and work hard. Are we clear? Okay. Any other questions? Any other questions before anyone? Okay. Some of you might play the strategy, screw up term test 1 and 2, and do very well for your final exam. Yes or no? It is a strategy. Right? So don't attend his class. Final exam, we focus. And I'm going to show you why that is a recipe for failure. Okay? I thought about it though. Okay? If I've done this, maybe final exam is 40 plus 10. If I really do well, term test 1 and 2, I can F it up and I can still pass. No, you will not pass. And now I'm going to demonstrate to you why you won't make it. Or if you look at the context of this course, what am I trying to teach you in this course? Okay, so it's like an introduction. Right. Let's go for the introduction. This is April 2024 final exam. Okay. Rod is made of steel. It's subjected to the load shown. Determine which element will fail. Element A, B, C, or D. Okay, do not worry. I'll post this on Avenue to Learn. It's all yours. You guys, each of you pay $1,000 for this course. You deserve all this, okay? Using Tresca ductile yield criteria, determine the diameter of the rod from the element selected in A, given that the ultimate strength is 45 KSI and the yield strength is 35. Why 2? Why do I give you ultimate strength and yield strength? Why not just one stress? So you have to have the ability to know why, and what you're using. Check that the selected diameter is safe. Okay. So how are you going to attempt a question like this? But before we go on, let's talk about an important aspect known as factor of safety, or we call it FOS. Can someone tell me what is the formula for factor of safety? Anyone? Pick up your phone, start Googling. Come on. Yep. So the ultimate strength divided by stress allowable. Okay. Now I start drawing a stress strain curve for you. You should learn all this very well by now. What is point A called? And what is point B called? What is point A called? Anyone? Anyone? And what is point B called? Can you see where the problem is? Why is it not the yield strength, but the ultimate strength? If you were to go to a textbook, I have not a clue what the textbook will say, but let's go there. If you were to go to a textbook that you have downloaded illegally, and the textbook will state, hey, maybe the textbook don't say anything anymore. This is from the textbook, and it quotes that the factor of safety is equal to ultimate stress divided by allowable stress. But if you look at the stress strain curve, what does it tell you? I'm not training this class where people will just question or follow formulas without questioning. You have to question this. Anyone? Yes. Yeah, but which value should you use? What makes sense? Yes. Yeah. Yeah. If you use ultimate, you use a factor of safety of 1.05, what will happen? You design leaning tower of pizza. Yes or no? But wait, hold on. I'm not saying the textbook is wrong. Okay? I'm not saying the textbook is wrong. Okay? So bear with me. Okay? Now, the black line that I draw down here is for what? Ductile material. Now we come to a point where we have a different type of material, which I'm going to draw in red, and it has a much higher Young's modulus, and then it breaks down here. So over here, this is stress yield, and then over here, this is stress ultimate. So over here, the red line represents brittle material. Okay. So what I'm trying to highlight for you is this. For brittle material, okay, factor of safety is equal to stress ultimate divided by stress allowable. Why is that? Because the stress ultimate is approximately equal to the stress what? Yield. Right? Can you see the brittle material? The yield and the ultimate, not a lot of difference. Okay. However, for ductile material, the factor of safety will be stress yield divided by what? Okay, let's make this very clear on the get-go. Are we clear? Okay. Now, anyone, any other questions? Okay, so as I say, not the textbook is wrong, but because it's just an intro. So this is what you learn in 2P. Yes or no? 2P states that what? Factor of safety is equal to what? Ultimate divided by what? Allowable. Nothing wrong with that. However, when we come to a material that is ductile, you have to change that to what? Use strength. And why? You can look at this graph and show you why. Okay. Now, the question asked, okay, so the question asked, for this case, okay, We were given ultimate strength and yield strength. Now, how are these tested? How are these determined? As engineers, we have to know how are things being determined. Yes or no? It's not like when I was undergrad, my problem don't really give a red S whether I understand or not. Until I work for Rolls-Royce, I make so much mistakes. It's like, how were these determined? Okay, so I believe 3CO3, you were taught how mechanical properties are determined. So how are they determined? So if you were to look at, this is from a materials handbook. On a materials handbook, what you can see is you can see the class of materials you have there. Then it states that you have an ultimate strength of what? In tension, yield strength in tension. Sometimes you can have yield strength in shear, and then the rest is normal. Okay, the rest are like you got